All right, welcome back to pre-calculus with trigonometry. If you're not in pre-calc with trig, this is probably going to be less effective for you. So what we're doing here is trigonometric equations. Again, this is a very common type of a problem I would put into to my calc class just to reinforce this topic. So this is something that we're going to do. Okay, so here we want cosine theta minus 1 equals 0. Okay, so we're going to say cosine theta minus 1 equals 0. So all we're going to do is say, okay, well, cosine theta equals 1. Okay, we went through and did that. And then we'll take the inverse cosine of both sides. Like what angle, cosine of what angle? Cosine of what angle is equal to 1? That's what we're asking. What does that have to, what does that have to be? You say, well, what does cosine look like? Cosine looks something like this. So where is it going to be 1? Oh, at the angle 0. Also, the angle of 2 pi. Anywhere else? Nope. It's only two places it crosses here. So we have theta is equal to 0 and 2 pi. It's actually also equal to every revolution around after that too. So 2 pi plus and then 4 pi, 6 pi, 8 pi, etc. Also, negative 2 pi, negative 4 pi. We can go around either way. Okay, so in this case, it's not a huge deal with this one, but that would be 0. And you have to be careful when you're looking at your domain here. Okay, they wanted the domain between 0 and 2 pi, but not including 2 pi. So even though over here I said this is for everything, so you might want to say this is, let's say this is 2n pi, for n is 0, 2, 4, 6, etc. That kind of a thing. Okay, so we can just get all the even values. But in this case, they don't want 2 pi. It's not included in our interval. Okay, remember the parentheses does not include. So 0, it's just theta is equal to 0, and that's it. Okay, so we'll go ahead and check. Okay, hooray, and then we can go off our lives. Okay, let's see. A lot of the problems that are in here are very much like that. Let's see if we can find something that's a little bit harder for us to do. Like this one. Okay, not exactly. Okay, these are getting a little bit closer to things that we would want to do. So this is going to be problem 4 and 5, but we have not quite there yet. Okay, so we have 2 sine x plus 6 is equal to 7. Okay, so how do we solve this? How do we solve this? So all we're going to do is we're going to just treat this like an algebraic equation until we have to go backwards. Okay, so subtract 6 from each side. So we're going to say, okay, that's 2 sine x is equal to 2 sine x is equal to 7 minus 6 is 1. Okay, and then divide both sides by 2, and we get sine x is equal to 1/2. Okay, where is sine x equal to 1/2? Well, that's going to be pi over 6. But sine is positive in both the first and second quadrants. So what is pi over 6? Whose job is it to be pi over 6 in the second quadrant? 5 pi over 6. Okay, we also have to deal with, well, that's actually it. That's all we have. It's just 1 pi over 6, 5 pi over 6. And that's just what's around the circle. Okay, notice that they only wanted this one time around the circle. Okay, so we're just going to type in pi over 6 and 5 pi over 6. So we're going to say pi over 6, comma, and then we want 5 pi over 6. Okay, and again, your book is very kind to you. They only expect you to do this one time. Not all books are this kind. Okay, so we'll go ahead and check that. Okay, and then they give us the green flag. And then for this one, let's see. Oh, it uses an integer. So the general solution. So what if they wanted to do this for like all the numbers? Then we would I think it would be best to break this up into 2 groups here. We'd have pi over 6. We'd also have pi over 6 plus, how about we say 6n pi 6. So that would give us 7 pi over 6, right? No, how about 12? 12 and pi over 6. So that would be 13 pi over 6. So 13 pi over 6 would be here. Okay, so it's just the coterminal angle to pi over 6, but we've gone around the circle once. Okay, where we can go around again, depending on what your n is. Usually n is going to be integer, so n will just be the element of the integers. Okay, we can go through that. But don't answer yet. We have more. We also have 5 pi over 6 plus, and then what we would want is going to be a 12 pi over 6. So we get 5 pi over 6, and then let's put an n in here. Okay, then we get 17 pi over 6, so forth. Okay, so we would want multiple versions of this. So for this one, right, we want 5 pi over 6. Here, right, that's pi over 6, but we also want that angle, that angle, and that angle. And how many times around? Oh, we can go backwards too. So we want 5 pi over 6, and then and plus 2n or 12n pi over 6, where n is an integer. Okay, and we do it that way. So let's see what general solution this is going to be. We have 2 of them. Let's see if we could say this. I would want pi over 6 plus 12n pi, 12n pi over 6. Okay, and then we would also want comma, and then we'd want our 5 pi over 6, 5, 6, and again plus 12n pi over 6. Okay, so that's going to give us all the solutions, and it doesn't matter that they only restricted the domain a little bit. It's okay. This is one of all of them. Okay, so in other books they're going to ask you for all of them, and I'm actually glad they added this to it. Okay, we'll go ahead and check and say, hey, how do we do? All right, check. Not really, sort of. Okay, there we go. Okay, so generally when I ask you a question, it'll be like kind of the part A part of this thing. Okay, but just be aware that your engineering classes may ask you for more times around the circle than your pre-calculus class did. Okay, so just be aware of the fact that this is only asking you what time around the circle. There's more. Okay, so thank you for tuning in, and I will see you in the next video.